Okay, so this is our final video on the organic section of your AS chemistry. There's so much to kind of retain in terms of the tests, the interconversions and things like that of all these different compounds, that what I find really, really useful is building something like this overview here, okay? Because, you can spend ages looking through your notes, oh, how do I turn a haloalkane into an alcohol, what's the mechanism, etc. Whereas if you've got this one-stop shop, you can just open up, say, do it on A3 piece of paper, and everything will be there for you to reference. And as you do questions, you can reference it and keep referencing it, and you'll get to the point where you don't need to look anymore. And of course, that's where we want to be, isn't it? So I highly recommend building something like this, okay? So very quickly, I'm gonna run through all the interconversions, okay? Like I said, some of these things you may not need to know for your exam board, like nitriles and amines don't feature in some of the new AS specifications, but you will need to do them at A2 anyway, so there's no harm in learning these now, okay? So I'm going to start over here with our alkenes. They tend to be our most reactive ones. So in terms of alkenes, okay, you need to know a test for that, which you'll remember is adding bromine water. And of course, there's some geometrical isomerism that you need to know as well. Okay, so make sure you know that. Now, converting an alkene to an alkane, that's known as hydrogenation. Okay, and for that, we need a temperature of 150 degrees Celsius with a nickel or platinum catalyst, all right? So that's our alkenes to alkanes. We don't go the other way. Now, over here, we've got our addition polymers, okay? That was another little section we needed to know. For that, we needed a catalyst. Okay, you can get the ones that react by catalysts, and of course, you can get these ones that respond to heat to form those addition polymers. And again, there are minor details. Maybe you could put some examples here. Okay. Now, onwards and upwards, we can convert an alkene to a haloalkane. Okay, so we can add a halogen into that alkene. Of course, you know that, or you should know that this is something called electrophilic addition, okay? And there is a mechanism that you need to know. Again, do this on a big piece of paper. Maybe you can sneak that in there, or do a little key and put it somewhere else, okay? What do we need for that? Well, one of two things. We can either just add the straight halogen, chlorine, bromine, iodine, or we can have the hydrogen iodide or hydrogen chloride or so on and so forth. Slightly, well, exactly the same mechanism, but slightly different kind of reasons why they react in terms of permanent dipole and induced dipole. Okay, so that's our electrophilic addition. We can actually go from an alkene to an alcohol. Okay, now, alkene to alcohol, we're just adding water. This is hydration. Okay, and for that we need phosphoric acid, so H3PO4. So that's our phosphoric acid there to our alcohols. And that's it really in terms of alkenes out to these other functional groups. Now let's fill in some gaps, okay? We can get from an alkane to a haloalkane, specifically the chloroalkane there. And that is free radical substitution. And again, it's not really a mechanism, your initiation, propagation, termination that you need to know there, okay? What conditions do we need? Well, we need Cl2 and we need UV light to produce those free radicals. So that's alkanes to haloalkanes. So that's that conversion there. Now, while we're at haloalkanes, okay, we can actually go back to an alkene. So I'm going to do this in red, okay? So we can go back to an alkene here. And to do that, we need NaOH in alcohol, okay? Now, it's really important, alcoholic sodium hydroxide. Heat that with it, and that will turn your haloalkane back into an alkene. And that is an elimination reaction, okay? You're eliminating HX, and it will turn it back into an alkene, okay? So anyone's going kind of backwards, I'll put in red. So our haloalkanes, while we're up here, we can actually convert into nitrile groups, okay? Remember, our nitrile is our C triple bond N group, okay? And we can do that by adding HCN or KCN, okay, and that will undergo a substitution reaction, okay, a nucleophilic substitution reaction. What you got to remember with these is you're adding a carbon to that carbon chain because of this here, okay? So don't forget that one. Our amines, we can actually convert a haloalkane to an amine by the addition of ammonia, okay? And that will again substitute that, that halogen for that group, and you'll end up with an NH2 group as an amine, okay? One last little thing here, you can get from nitriles to amines, okay, and that's reduction. Okay, so where you see oxidation and reduction, I'm just going to put it like that. And our reducing agent is LiAlH4, lithium aluminium hydride. So that's going to reduce the nitrile to the amine. Okay. Right, onwards and upwards. We still need to kind of link the alcohols and everything to this. Okay, so this is a little section all on its own. I'm going to go from haloalkane to an alcohol. Okay, now a haloalkane to an alcohol, that's NaOH again. Okay, but this time it's aqueous. Okay, so that's the difference here. Alcoholic NaOH gives you the alkene. Aqueous NaOH gives you the alcohol. Now, of course, that's heat as well, and that is nucleophilic substitution. All right, so you do need to know the mechanism for that, ladies and gentlemen. Okay, you do need to know the mechanism for that. Now, to go from our alcohol to our haloalkane, we can do that using a reagent called PCl5. Okay, so we can convert that in terms of adding chlorine using PCl5. Right, so now we get into this section here. There's a lot of interconversions, okay? But first of all, I'm going to be able to convert that alcohol back to an alkene. Now that is kind of elimination, but we're adding water here. So we're removing water here, okay? So this is dehydration, and for that, we need conc H2SO4. Concentrated sulfuric acid is a really good dehydrating agent, and it will get your alcohol and turn it back into an alkene. Now, alcohols. So we can turn an alcohol into a ketone, but we need a specific type of alcohol. We need a secondary alcohol, okay? Now, in terms of oxidation here, which is what it is, there are a couple of reagents that we can use, okay? I'm just going to put it down here. So oxidation, we can either have acidified potassium dichromate, O7(2-), or we can have acidified potassium manganate 7. Okay, so either of those, and you need to know your color changes. Okay, orange to green, purple to colorless. Okay, for your oxidation from alcohols to a ketone. Now, because these are not further oxidized, okay, we can use reflux here, okay? So we can just heat it and keep reacting and maximize our yield using reflux, okay? Now, alcohols to aldehydes, okay, again, is oxidation using either of our reagents here, but this time we need to distill it. Because if we continue the oxidation, our aldehydes further oxidize to carboxylic acids, okay? So if we wanted to oxidize that alcohol all the way to carboxylic acids, we just reflux it, bypass all the aldehydes, and jobs are good, okay? But if we want to isolate the aldehyde, then we would have to distill it. Now, in terms of the opposite way, okay, of course, the opposite of oxidation is reduction, okay? So we can go from a ketone or an aldehyde to an alcohol, depending, obviously, whether it's built by a primary or a secondary alcohol. Reduction using LiAlH4, that will reduce it back to an alcohol. What we can't do is this step, okay? Because our reducing agent is that strong, it will actually bypass the aldehyde and go all the way back to the alcohol, Okay, so you cannot convert carboxylic acid to aldehyde. You'd have to go back to the alcohol and then distill it back up using oxidation. Now, last bit, okay, our carboxylic acid to an ester, okay? Now for that, we need to react it with an alcohol, so an ROH, so they come together, okay? And we eliminate water, so it's a condensation reaction. But as a catalyst for the reaction, we need sulfuric acid. And that sulfuric acid, like I said, acts as a catalyst to form our ester, sweet smelling ester for a product for that reaction between carboxylic acids and alcohols, okay? Now that's it, okay? There's a lot there, okay? But I promise you, you build something like this and you keep referring back to it and it will stand you in good stead for learning these reactions, okay? The only thing, like I said, you need to add are these mechanisms maybe, okay? Possibly your test, you need a test for a haloalkane, your amine, you can test for an alcohol, okay? And obviously test for aldehydes and ketones as well, so you maybe put those in there. Test for a carboxylic acid, we've got a test for an alkene, okay? Alkanes are very unreactive. So you could put those tests in there as well. Don't overface yourself, don't put massive amounts of detail in there. Make it as big as you can, make it as clear as you can, and reference it. And like I said, fingers crossed, you're going to get to the point where you don't need to reference it anymore, okay? So the sooner you can put this together, the better.